Hello and welcome to Science with Mrs. Blackburn. Today we're going to start talking about the laws of motion, and this will be the first of two videos that I do this week. Today we are going to talk about several things. So here's what you're going to get out of today's video. We're going to define what a force is. We're going to talk about the different types of forces that exist. And then finally we're going to explain how forces are measured. And these skills that you learn today are really the basics of physics, and you will hear about these not just in this class, but as you progress along in all of your science classes all the way to college. So let's go ahead and just get started. So a force. What is a force? Well, if you've been in my class, you know what I think about when I think about the force. Okay? But today we're going to talk about physics forces. So a force is actually just a push or a pull. It is that simple. A push or a pull on something. Now, it gets a little bit more complex though. We have two main types of forces that exist out there. Two main types of pushes and pulls that can happen. We have contact forces and non-contact forces. So let's talk about contact forces for just a moment. A contact force is just a push or a pull on one object by another object that is touching it. So a contact force has to involve contact, just as the term says. So it's a push or pull on an object by another one that is touching it. Okay? So let's think of some examples of contact forces. When you do something like kick a ball, that's going to be a contact force because you're actually touching that ball. Pulling a wagon. Okay, pushes or pulls are forces. Lifting weights. You have to touch that weight to actually lift it. And pushing something up a hill would be a contact force. So all of these forces involve some sort of touching or contact to involve those pushes or pulls. So let's talk about non-contact forces. A non-contact force is going to be a force that one object can apply to another object without touching it. So these are kind of neat, and they're actually all around us. Things like magnetic forces. So if you've ever played with magnets before, you know that they are going to attract or repel different things without even touching them. You actually feel that force. You feel that push and that pull on a magnet. Electrical forces are also non-contact forces. They're going to create pushes and pulls and movement without even touching anything. A good example of this is like static electricity. If you've ever rubbed a balloon across your hair and then you move the balloon away but your hair is still attracted, the balloon doesn't even have to touch your hair to make that hair move. So that's going to be a non-contact force. Even gravity is a non-contact force. Gravity, and you know, if you've ever fallen before, you know that gravity can be a pretty crazy force, a pretty strong force sometimes, and you don't even have to touch anything to feel that gravitational force. An important thing to think about is all of the things that we discussed with space science and the Earth, Moon, Sun system and the solar system and all of that. We've already discussed gravity a little bit, but it is one of these forces that we're going to be talking about. That is a non-contact force that things don't have to touch to feel the force of that pull of gravity. So, let's talk about some important things about forces. So here's something important about forces. They have a strength and they have a direction. And this is something that is going to be a big deal in physics, and you're getting the basics, and I kind of get really excited when we start talking about things like that because I know where you're going with this, and this is the first time you've ever really talked about it, so this is actually a really cool thing, so make sure you're paying attention. So a strength and a direction. So the strength of forces are measured in a unit that we call newtons. The abbreviation for this is just a capital N. So we actually quantify the strength of forces. When I say quantify, I mean we put a number to it, okay? So it actually got its name from who we call the father of physics. That would be Isaac Newton, okay? Exactly who you're thinking of, Isaac Newton. That's what that unit is named, who that unit is named after. So how much is a newton? Just to wrap your mind around the amount that you're talking about when you talk about 1 newton of force, it would be about the force you feel when you would hold 100 grams of something in your hand. Okay, so that's the amount of force. Or if you were to push 100 grams of something, that's the amount of force that you would have to apply to it to move it. So coincidentally, an apple is about 100 grams. So when you think about the force of an apple being dropped into your hand, that would be about 1 newton. Okay, 100 grams. So the direction of a force, the second thing that we need to know about forces is that they also have a direction. So the direction of a force is going to be shown with an arrow. So if we discuss forces and how they're being applied to an object, we use an arrow to show that. So let's look at an example of this. So right here we have a little picture of 2 guys playing tug of war, and we see that one guy is pulling the rope to the left, the other guy is pulling the rope to the right, and we're showing the forces, the pulls that they are applying to this rope with these arrows. Okay, the one who's pulling to the left has an arrow above him going to the left. The one pulling to the right has an arrow above him moving to the right. So if you are asked to talk about forces, which you will be later this week, and asked to draw some diagrams of how forces are being applied, you will draw arrows to show the direction of the forces. Okay? Now, the magnitude of forces, so we talked about how big a force is going to be shown in newtons, but the magnitude of forces can also be shown with different sized arrows. So here on this graphic, you're going to see up at the top, you have a tennis ball being hit with a force of 300 newtons right there. And it's also shown with a red arrow showing the direction that it's going to go, the direction that that force has been applied to the top right. Down here at the bottom, in contrast, we see a little ping pong ball being hit with a force of 100 newtons, which is much less. In the same direction, it's going to the top right here, but notice how the 100 newton arrow is going to be much shorter than the 300 newton arrow. So the magnitude of forces are shown with different size arrows. So this word magnitude is actually something important that we need to talk about with physics. Magnitude just means how big something is. It's a big word that just basically means how big something is. So how big a force is will be shown with a different size arrow. Okay, so pretty simple video today. Today we have talked about 3 things. We've defined what a force is. We have discussed the types of forces that are out there. So we know that there are contact forces and non-contact forces. And we have also explained how forces are measured. We know that they are measured in newtons and that they are shown by different size arrows, which are going to show the magnitude, how big the force is, or how many newtons are applied with the force, and arrows that are going to be in different directions to show the direction that the force is being applied. So we've learned 3 pretty big things today. So really good job with this video, and we are going to talk more about this week. So for now, I had to do it, guys. Forgive me. May the force be with you, and have a wonderful day.